And welcome, viewers, to the Daily Space Weather Show. Pardon our absence yesterday. There were some technical difficulties. Today's custom videos, they all feature 48 hours instead of the normal 24 hours because, well, we missed a day, so we're making up for it. We decided to release this one early today on Sunday, the 4th of February 2024, because we wanted to get the video out as a solar flare watch. So this new sunspot in the southeastern limb is certainly a major solar flare player. We also have a sunspot in the southwest. So both the southeast and the southwest are growing major solar flare watches. So in your lower right and your lower left, see some significant activity going on there. Let's take a brief look at sunspots here. There is yesterday plus today, and we'll see another uptick in the sunspot number before tomorrow's daily space weather content. There is the colorized magnetogram for the same period, February 3rd and February 4th to date. We'll briefly look at volcanoes. These are the ones that are erupting. There's a great view of Mayan, which created some block and ash flows and a bit of an ash flume during a phreatic eruption. Mount Ibu also exploded. Dacono, Kilauea has had its alert level lowered to yellow. Popocatépetl, Fuego, Nevado de Ruiz, Revenador, and Sabancaya also on the list of erupting issues. Here are the past 90 days of seismic activity. It's been pretty quiet over the past 24 hours as far as earthquakes go. There are the recent quakes at Hawaii. We'll zoom out to the full-size map here to cite quakes of a 5 and greater magnitude. So only a couple issues of a 5 or greater magnitude there, like this 5.1 at Peru this late last night at 23:30 Universal Time. Tonga had a 5.2 at 4:46 this morning. Guam had a 5.4. That was at 9:50 this morning. And that is it for quakes. And let's take a look at some more sun stuff here. That's not bad. Here's a 48-hour video. Now we've got SDO 171 plus 131 angstroms. Take a look at this new sunspot. That one doesn't have a name yet. By tomorrow, it certainly will. It is the TMAS, the most active sunspot for the past 48 hours. And before we get to things like coronal holes, let's take a brief look at what's going on for things like the radio flux. So 10.7 centimeter radio flux now at 156. 156 solar flux units for the 10.7 centimeter radio flux. The one-year chart shown here depicts the radio flux as the black line. The red line is a sunspot number. Notice how proportional they are. When you see a high radio flux, you see a high sunspot number, and vice versa. And by the way, wild swings in sunspot number is an absolutely normal thing around solar maximum. We also see sunspots at all active latitudes. We'll get to that momentarily. First, the Space Weather Enthusiast dashboard here forecasting a little bit of geomagnetic unrest, possibly geomagnetic storm conditions tonight. So it could be a night for aurora chasers. It's because of a combination of coronal hole high-speed streams as well as possible transient impacts of coronal mass ejections. So we also did forecast one showing up sometime early in the day on the 6th. That could be a thing as well. So it looks like NOAA's not really forecasting that one, though. So there you go. That's NOAA's forecast. You can see if you watched our previous videos, it's a little different from ours. Next, the past 4 hours of Earth's magnetic moment from space. This depicts magnetohydrodynamic pressure. It is the Geospace Magnetosphere movie. It's showing Earth to about 12 Earth diameters. And we do have geomagnetically calm conditions. We are seeing a weak coronal hole high-speed stream currently buffeting Earth's magnetosphere, not causing any major effects, although we did recently see some shifts of the magnetic field orientation. That is unlikely to produce any major effects like geomagnetic unrest or geomagnetic storm conditions. But those are the past 4 hours. Past 4 hours of Earth's magnetic moment from the ground looking like this. This depicts magnetic flux density at the ground level. And by the way, you can use that map to see the most likely places to see the aurora. We've done it on the channel. We've actually taken some auroral videos and photographs all the way down here in Lehigh Valley, Pennsylvania. So that's the past 4 hours of the ground level magnetic perturbations. KP index only at 1.67. KP 1.67 is the current state of affairs. Geomagnetically calm conditions. Next, the solar wind. And there's the ACE showing about 2.5 protons per cubic centimeter at 400 kilometers per second. The Discover showing about 8 protons per cubic centimeter at 426 kilometers per second. So right here we see a prime example of the coronal hole high speed stream that we typically see. So here you'll see the telltale signs of a coronal hole high speed stream. We see an increase in solar wind density, and when it decreases, you'll see the increase in solar wind speed and a solid signal there of higher plasma temperature, or just different plasma temperature, really. So there you go, coronal hole high-speed stream, although it's kind of weak. Not super fast, although it is kind of dense for a coronal hole high-speed stream. Also, if you look at the top pane here, you can see that, yeah, that's the BTBZ. The BZ there swinging into negative territory. So that's the vertical component of the magnetic field there. The white number is the actual magnetic flux itself. So 7 nanotesla at a BZ of -5. So that's a little bit more conducive to generating currents in the Earth system. Although, again, unlikely to produce any major effects like geomagnetic storms. Next are GOES magnetometers. And the GOES are at like 23,000 miles of altitude, way out there in the outer portion of Earth's magnetosphere. There are the readings from the GOES 16 and the GOES 18. No major effects, although you do see some sawtooth happenings there. That's a coronal hole high-speed stream. Next, our top view ecliptic plane field plot. And Earth now in a South Pole-oriented magnetic sector, depicted by the red potential field surface source lines there. There's the latest image. A little tiny South Pole-oriented sector there. So it's not going to last long, not likely to last long. Keep in mind the magnetic environment can change with basically no warning. Here is our line of sight field plot. And this is probably the most compact data that you could have. I mean, that's like a poem of solar activity right there. Solar B field in blue, photosphere magnetism in grayscale, and polar fields in green and red for north and south, respectively. Coronal holes are next. And it's looking like a very small South Pole magnetic sector there. Could see a North Pole sector return as early as tomorrow's daily space weather video. We'll have to see what happens there. Let's switch to coronal holes from SDO. So there are the past 48 hours of SDO coronal hole imagery. The fantastic 211 angstroms wavelength is excellent at showing coronal holes. Which brings us to sunspots. Now, like I said earlier, major uptick in sunspot number coming tomorrow. We're expecting it to be up to about 170, or at least in the 160s. At the moment, sunspot number at about 135. So 135 as it pulls the average up higher and higher as we get closer and closer to solar maximum. Can't believe it's controversial to say that. And here's our synoptic map. And you can see a likely proton event, only a 15% likelihood of a proton event and a 15% likelihood of an X-flare. So this forecaster from NOAA tends to agree. That's Spencer. So yeah, we put out the video early because of the likelihood of large solar flares, especially from 3576 and 3575. Now, another thing I'd like to mention here when we get to the actual imagery is the latitudes of sunspots. So anyway, as you can see there, a very high likelihood of large solar flares. especially in that southeastern limb, followed by the southwestern limb. So 3576, the most likely place, 3575, the second most likely place to see a large flare. And let's switch to sunspots here. There's a 48-hour video depicting the HMI continuum as well as the AIA instrument, 171 angstroms. Let's zoom in a little bit closer there. So some new sunspots have formed since yesterday, it certainly looks like to me. Here we've dropped the 171. Yeah, so major growth there in the southwest, major sunspot flare player in the southeast, and a bunch of new sunspots there forming in the northern hemisphere. So sunspot number likely to exceed 160 by tomorrow's daily space weather video. And let's talk about the latitudes of sunspots. Yeah, the latitudes of sunspots. So, at solar maximum, you can expect to see sunspots at all active latitudes. In other words, way down here close to the poles, as well as around the equator. Around solar minimum, we only see sunspots around the equator. So, a prime example here of getting closer and closer to solar maximum, with sunspots at all likely active latitudes. Exactly what you would expect for an average, or even possibly slightly above average, solar sunspot cycle. Solar cycle 25. By the way, if you haven't seen the Ask a Particle Physicist segment, check it out. We have a playlist for that, Smash-O-Mash, youtube.com/Smash-O-Mash/playlists. We just uploaded the latest ones. And if you want to see this week's Ask a Particle Physicist segment, you would have to do that for segment 11. And yeah, segment 11 is the newest one. And it's only available to, that one's only available to paying Smash Team members. So if you're a Smash Team member at the gold or silver level, then you'll be able to see those videos stand alone beforehand. Otherwise, they're in the daily space weather video for the Friday in question. So that's the current situation. New playlist there, relatively new playlist, the Ask a Particle Physicist segment. So now that is hosted by the monotone from Minsk, known as Eugene the Philosopher. So make sure you subscribe to his channel if you want to contribute to the Ask a Particle Physicist segment. Head to smashomash.com/forum. And just head to the General Science Forum, and right there you'll find the Ask a Particle Physicist segment. You too can contribute a question. And again, make sure you subscribe to Eugene the Philosopher. Eugene the Philosopher, the monotone from Minsk, and host of it's our resident particle physicist. Maybe we'll have to put him on retainer, folks. What do you think? Should we salary Eugene? Let us know in the comments what you think. Again, make sure you subscribe to Eugene's channel. It's got some insightful videos on there about things that you may have not thought of. Now, before we get to solar energetic particle events and flares, let's talk about energetic particles coming from outside the solar system. That's kind of important, right? Cosmic rays. We haven't done a report for a while, maybe even over a week at this point. So let's take a look at cosmic rays. Cosmic rays are up at all the major monitors. So there's Oulu, Finland, showing an uptick over the past 30 days. DOMB Antarctica showing a slight uptick over the past 30 days. DOMC Antarctica, slight uptick over the past 30 days. Heading down south to Mexico City, a slight uptick over the past 30 days. Heading even further, or a little farther north to Athens, and Athens looking crappy, but still looks like an uptick over the past 30 days. Last but not least, Apatity and Barentsburg, similar upticks over the past 30 days. And by the way, you can expect cosmic ray flux to continue declining for the next about 18 months. Yeah, about 18 months of cosmic rays expecting to decline. So we're already at the lowest levels in 20 years. If we go back to the Oulu neutron monitor, you can see that great. So right here, see that line right there? That goes all the way back to 2004. Lowest levels of cosmic ray flux since 2004. A 20-year low in cosmic rays. So, I don't know, maybe that's controversial. If so, too bad. Those are basic facts. Cosmic ray flux at the lowest levels in 20 years. And you can expect them to get even lower. Next, looking at solar energetic particles, and we ain't got no new ones. We're back to baseline levels for the GOES proton flux. And as far as the X-ray flux, we've seen a major uptick in the X-ray flux, mainly from that new sunspot in the southeast. So the background flux now all the way up to about a C2.3. And multiple M-class flares, at least 4, in the past only few hours. Let's take a look at flares from SDO. There is the 94 plus 131 angstroms wavelength together. And again, the T-mass, the most active sunspot, is certainly this sunspot down here in the southeastern limb. Once again, just to reiterate, we do have a rising likelihood of large solar flares from this sunspot as well. So don't be surprised to see an M-class flare possibly from that group. Most likely place remains in the southeast. Anyway, moving on to a star chart. So this is what's going on overhead right now over Lehigh Valley, Pennsylvania. There you go. Just click the Now button after you've put in your location. We've got the Big Dipper is up there, circling Polaris as it does. You've also got Mars and Venus setting there ahead of the Sun, as well as Mercury, as Saturn trails the Sun. So if you're viewing the early evening sky, you might be able to see Saturn and Jupiter up high on the ecliptic. Also, to our Northern Hemisphere viewers, did you know the Big Dipper points at the North Star? So here's the Dipper. And these stars at the end point right to Polaris, as you can see here on the chart. You're looking for the North Star, and you can find the Big Dipper, which is very conspicuous. There it is. It's part of the Little Dipper, and it points right at Polaris. Next, our solar system forecast. We'll show you where things are today, and then we'll show you where things are going to be in 1 week. Here's where things will be in a week. New moon coming in a few days. We will have a crescent waxing moon by the 11th February. Next, a great image from Hubble Space Telescope. And this one is The Pillars of Creation. A very famous image from the late 90s, I think, originally is first time we saw that one, maybe mid-90s. And you've got a bunch of very, very dense, dusty regions there with some hot, bright, active stars illuminating that area. So just spectacular imagery there from the Hubble Space Telescope. Dag. That ain't half bad. That is some dense, dusty space indeed. apod.nasa.gov if you want to check it out yourself. Next, how about if we do some CMEs? Here are CMEs from yesterday. And yesterday was pretty chill. I don't think any new CMEs there from yesterday, not earthly directed ones at least. And as far as today, there are an additional 75 frames from today. Still pretty chill there. No new CMEs in the past 48 hours. So there's LASCO C2 and C3. Let's just skip that and tie those together. 2 new comets there showing up, by the way. These are 48-hour videos featuring LASCO C2 and C3 as well as SDO. That's 304 angstroms. And look over there on the left side, you see 2 comets showing up. There's one. Here's a little closer view. And no real CMEs of note for the past 24 hours. Here we've dropped C3 and added 193 angstroms to the 304 angstroms SDO imagery. Once again, these are 48-hour videos. Here's an even closer look at El Sol. And here's an even closer look at El Sol as we transition to solar filaments. Filaments are next. So let's do it. There are the filaments from Cerro Tololo, Chile. Yeah, not El Teide, Spain. Cerro Tololo, Chile. And there's a colorized view, or the colored view, or whatever you want to call it. Color images. Some dense filaments there making their way into the Earth-facing portion of the disk. Quite a few smaller filaments there. So certainly a potential for large coronal mass ejections, proton events, and large solar flares. Again, that's why we put the video out early today. Before we get the bonus features, let's check out the last couple of hours. Major solar flare watch in that southeastern limb especially. Anyway, here come bonus features, starting out with satellite charging hazards. We don't have any. It's smooth sailing for satellites here. No surface or internal charging hazards. No likelihood of any kind of major satellite abnormalities. GOES electron flux here remaining in a normal operating range. Nothing too exciting there. There's the 1-year graph of the electron flux coming up off the floor as forecasted following the latest coronal hole high-speed stream. There's a forecast model. And NOAA is expecting a downtick. I would tend to agree. That looks like about right. That next green box, that is where I would tend to agree with that. Maybe the observation will be a little bit lower, but it should be close to that. And next, let's show the ionosphere. Now this time we are only showing 24 hours of the F flare. And there it is, the F flare. And what's shaken? Megahertz are millions of vibrations per second at the bridge between Earth and space. So, of course, on the Earth side of things, you have the D layer of the ionosphere. That's where the Schumann resonances and the radio signals are refracted. The F layer is more interactive with space. So the D layer is more neutral, the F layer is more ionized, and the ionosphere is kind of the barrier between Earth and space in many ways. That's what's going on. Here's the anomaly in megahertz from a 30-day median. And no major anomalies happening here because no significant space weather has been showing up. We'll also show the Global Ionosphere Nowcast, or WAM, the whole atmosphere model. Total electron content on the left, maximum usable frequency on the right. We'll close out the space weather content with the latest high-res images. And let's take a look at those major sunspots here. First, this one. And that's Beta Gamma Delta class. The most likely class to produce a large flare. So there you go, Beta Gamma Delta class. And this one over here, look at the ombre there. That is impressive. Wow. Huge plage behind that as well. So that we are seeing quite a bit of plasma instability back there. So, and let's get to Earth weather on this fine Sunday afternoon. We're going to start things out with sea surface temperature anomaly. So there's the Atlantic Ocean. Sea surface temperature anomaly and surface winds are what we're showing. The color gradation is sea surface temperature anomaly, and the animation is surface winds. Surface winds of the Southern Ocean and sea surface temperature anomaly. There is the Indian Ocean, the Pacific, the mighty, mighty Pacific. And there is the Arctic. Next, visible satellite for the Americas. Since we made this video so early today, using the visible satellite imagery for once instead of the shortwave radiation map, which we usually show as we usually make the videos around sunset for this time of year. We do have a very interesting weather pattern here. We have a bunch of moisture that is kind of making its way all the way up into Canada, which is kind of a funky weather pattern. Not really too normal there. But the major thing that's running the weather in the U.S. right now is this low. So this low off the coast of Southern California is really moistening things up. Let's take a look at that. There's a fantastic view of that low pressure, which is bringing shocking amounts of rain to areas just north of Los Angeles. You can see that counterclockwise rotating low. The center of it's right about here. As more Banzai pipeline water shows up, inundating California with moisture. So there's that low. And let's take a brief look at precipitation type. As a bunch of rain and wet snow are making their way into California. Check it out. A lot of precip happening there. Almost the entire state currently experiencing some precipitation. So rain with snow, wet snow, snow, and rain currently showing up at California. Let's briefly take a look at pressure once again. I'm going to bring pressure back up. So there's a pressure map, and let's move on to our weather.gov map and look at all the warnings in California. There is some shocking flooding coming. Where do you see the rain forecasts? They are berserk. They are very bulky rain forecasts. Let's do it. First, the pressure and precipitation forecast. And dag. Just loitering moisture there from the Pacific Ocean. So check out the inundation here. Those forecasts are for a foot of rain. At least 10 inches of rain there in portions of Southern California. So there it is, pressure and precipitation. We also showed total accumulated precipitation in inches. That is the GFS 72-hour model. We'll also show snow totals, which will be 3 feet in some areas there. Large portions of California, they're expecting 2 feet plus. 72-hour GFS accumulated positive snow depth change in inches. Last but not least, temperature anomaly forecast as we enjoy really warm temperature, unseasonably warm temperatures here in Pennsylvania today. Forecast high 50 degrees Fahrenheit. Again, these temperatures are in Celsius. Temperature anomaly in degrees Celsius. 72-hour GFS model. Lightning, and that looks like utter garbage, so let's just skip that and go to a real-time lightning map, courtesy of lightningmaps.org. Next time you hear thunder, check it out. Convince the natives that you're Zeus or something. That could be fun. We do have some lightning here around Florida. Florida, the Australia of the United States. Many of you may have seen videos about Florida Man. And there are plenty of Florida men making YouTube videos in Tallahassee, ending up on YouTube police arrest videos around Tallahassee. Right? Am I exaggerating? Let us know in the comments if you're from Florida. You may have met Florida Man. And congratulations on surviving that meeting. We'll close out with U.S. Doppler, visible satellite, and water vapor. So there's a full 50-state view. Quite a bit of precip on the lower 48 view. Dag. There's the visible satellite. And there is the water vapor map. You can see an atmospheric creek, like I mentioned earlier. Atmospheric creek, making it all the way up to Canada there, as sending some moisture back to Canada. Consider that moisture returned, eh, ya hoser? Here's a recap. U.S. Doppler radar. Visible satellite. And last but not least, the water vapor. And thanks for tuning in to the Daily Space Weather Show. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And until next time, may that solar wind be at your back.